The broadcast is now starting. All attendees are in listen-only mode.
This is the SmartNet Fall 2017 Fall Update and Adjustment Launch. This is a re-recording from yesterday's actual webinar with customers on the line. So if you are re-watching this and trying to catch something I might have said during the original webinar, I apologize. We did lose that recording, so we are redoing this today and going to cover all the same topics. Won't have some of the same questions, and of course won't say exactly the same thing, but we will cover the meat and potatoes of this as we go. So let's get started. So for this webinar, we'll be covering a number of different topics. We'll be covering by the numbers, new developments with network RTK, specifically update on GNSS corrections. We'll be doing and focusing a lot on the fall adjustment that is being launched in about a week and a half, and then spend quite a bit of time talking about multiple reference frames, what this allows us to do in either areas of movement or in areas that have legal challenges or legal requirements that we need to be in alignment with. We'll also talk a little bit about coordinate and epoch tracking, how you can look at what coordinates are there and available to you on different sites throughout SmartNet, and then of course on the horizon and wrapping up. So a quick update on SmartNet. We always like to show this slide in a webinar to kind of show you the progression and where we come from and where we're going. A few numbers for you. We're now at just over 1,300 stations in SmartNet with over 1 billion acres in coverage. We're very proud of that 1 billion acres. It's a good big number. We're going to keep adding to that in the coming months and years. 43 states are now serviced by SmartNet. 8 Canadian provinces are now serviced by SmartNet, and we have coverage in 461 of the top 500 metropolitan statistical areas. That means in the U.S. we cover about 265 million folks, and in Canada about 27 million people are covered. So we like to show this slide as well. This shows where we were a little over two and a half years ago. We footprint in the major urban centers, and over the last 2.5 years, of course, we've had a dramatic growth and a dramatic increase in coverage, either by expansion or acquisition or merging of other networks. So this is our over billion-acre coverage. The areas, of course, in the bulbous kind of polygon areas are network coverage, and the ones that are round, of course, are single baseline coverages. But now coverage in a lot of different areas, and hopefully this has gone a long ways to expanding the footprint you have available to you as a customer, or give you the ability to use it even more in your day-to-day operations. So a few new developments with Network RTK. The biggest development this year, of course, aside from the expansion activities, has now been the expansion and availability of new constellations and new satellite signals. These future satellite signals are no longer in the future, they are today. We now have 12 GPS L5 satellites in the current constellation, which is a big improvement. Of course, Galileo now with a launch of 4 satellites last year, bringing us to a functional constellation with Galileo now 18 in the current constellation, still 2 that kind of are under commissioning or dropping in and dropping out, and then 4 additional are scheduled here late in 2017. I haven't checked and looked at the launch dates to make sure they're holding to the late 2017 timeframe, or if it's being pushed into early 2018, but regardless, we still have a lot of Galileo satellites that are available day to day for your use out in the field. In addition to that, you also have the Beidou constellation, which does have some satellites currently invisible out on the central and western United States, central and western Canada. You can see 1, 2, maybe even 3 Beidou satellites, depending on what time of the day. In the central east, there may not be any available. This will change in the coming years, of course, with projected global coverage coming in somewhere around 2020 to be more one-to-one relationship to what Galileo or what GPS provides. And these are all great things, and they have a lot of great advantages out in the field. Now, we did talk about GNSS corrections in great detail, in a lot more technical detail in a webinar we did back in late May, early June, when we actually launched our GNSS correction services. So I encourage you to go back and watch that webinar. You can find that under the support knowledge bases under webinars. You will see the GNSS launch, and I think right now today actually it's at the top when you first get to support.smartnetna.com. So if you want more information, please refer back to that. But we want to give a quick primer here. What it does really mean for you guys is more satellites. Now, more satellites doesn't mean higher accuracy, but it does mean better availability in canopy or canyon environments. Of course, canopy would be trees. Surveyors tend to love to run off into the trees with GPS, or in canyon environments, meaning urban canyons where you have large building hardscape obstructions left and right, front or back of you. It doesn't necessarily mean higher accuracy, but it does improve the reliability and solution. If we think about it from just a pure geometry standpoint, we do have more strength of figures when we have satellites in front of us and back of us, left and right of us, side of us, and in the canopied environments or in the canyon environments where we have stronger geometric form because all the satellites aren't squished together, that is going to improve the reliability of the solution, but not get us any higher accuracy, meaning that if I'm in a wide open area, I'm still going to see a 1 to 2 centimeter solution with even a full GNSS constellation. I'm not going to see that drop down to half a centimeter and 1 centimeter vertically. You're still going to be fighting with just physics. So you won't see a higher accuracy in open situations. You may see a little bit better accuracy in canyon or canopied environments because of more satellites, but this is also an increase in reliability of your solution. One of the other thing, aside from more satellites, triple frequencies, third frequencies or additional frequencies on the same constellation, such as L5, or as you move into Galileo, having 4 frequencies available to you. This does allow for improved ionospheric modeling. This is very important as we move towards solar max sometime in the coming years, as we use the L5 signal to improve that atmospheric modeling. We should see improvements in the field in your ability to work during those high atmospheric activity conditions. Addition to that, the possibility of longer baselines is out there, so we may not be really limited to 40, 50 kilometer baselines, maybe push that out further, but of course that does take additional development work now that those frequencies are available both on the network side in addition to the rover side. So that's something that you can look forward to as we go. In addition to all that, this is a really good view in the real world of what it means. As opposed to just talking about it, this can kind of show it. And also getting out into the real world yourself with a GNSS rover and showing yourself what it can do and trying to take not only measurements in difficult positions, but also trying to get repeatable measurements in those difficult positions. Because if it's not accurate, it really doesn't matter if I can get it right up against a building if it's not going to be a good solution. This is in a test canyon environment. So left, you got a 6-story building. To the right, you've got a 1-story building, and you were able to fix with a mix of GPS, GLONASS, and Galileo satellites, which is really impressive, especially considering where this sits. For a canopy environment, this is actually in the trees with a 1-story building. I think the 1-story building is to the south as well, and the receiver was able to fix with a lot of satellites. So here there was 25 satellites available, 10 GPS, 8 GLONASS, 5 Galileo, 2 Beidou. I think on this there was also 3 or 4 L5 satellites available during this measurement as well. And not only getting the measurements important, but in this test, there was actually a nail put in the ground, and the rover came back out and repeated this measurement throughout the day. And of course, the important part, it was able to tie back to the original measurement within the 3D CQ tolerances for each individual shot. So that's a key element, not only being able to fix, but to be able to fix reliably. So the correction update, what does this mean? Well, before we could even get to GNSS corrections, you really have to have each part of the network available to be able to handle that. Now, when we talk about the networks, we typically talk about it with 5 pillars, being here on the screen: the GNSS reference station infrastructure itself, the IT infrastructure, the correction service, online tools and resources, and of course the support and development team behind that. So to be able to offer GNSS corrections, the GNSS infrastructure, that means the receivers out in the field, the IT infrastructure where the data comes into, and the service and software platforms must all be GNSS capable to deliver a true GNSS correction. So the first part of that, and probably one of the hardest parts of that, is the infrastructure out in the field. This means all the hardware out there has to be capable of tracking the satellites that you want to use on your rover on the reference stations. So this requires a great deal of time, effort, energy, and investment to be able to tackle this. With SmartNet now, we are 99.9% GPS and GLONASS capable. We still have one little GNSS, or excuse me, GPS only receiver out there that's going to get tackled here in the not too distant future. 76% of SmartNet is now GNSS capable, meaning GPS, L1, L2, L5, GLONASS, Galileo, and Beidou. In this area here in the bottom, you'll see these are 100% GNSS capable areas. Now, GNSS capable areas doesn't mean the hardware is capable of it. We do have, I think, one area, Iowa, that still needs a few codes loaded on the receivers out in the field. So if you go out and you do see that you're in one of these areas that we talk about being full GNSS, and you see you drop down to GPS GLONASS only, and GNSS isn't happening, and it happens a couple times, let us know in the area you're in so that we can go back and look and making sure all the hardware, all the receivers, and all the codes are activated for the particular region that you're working in. We do have about 1,300 stations now, like I said earlier, so we do sometimes miss a station or two for those codes or making sure that the settings are uploaded. If the station got reset, the defaults are GPS and GLONASS, so we do have to make sure we check the boxes to reload Galileo and Beidou sometimes. So if you do see where GPS or drops down to GPS and GLONASS and you don't get GNSS, and you are on a GNSS mount point, which we'll talk about here in just a couple slides, let us know and we'll make sure that the codes are activated or that receiver is ready to go. And you can do that, of course, to support@smartnetna.com. On top of the GNSS infrastructure, the IT infrastructure also has to be capable of handling all this new data that's coming in. This means more processing power. This means more memory. This means more bandwidth. This means more storage. This frankly means we have to harden and optimize our entire IT stack to be able to take in all that additional data, take it, process it, and then send it back out to you without inducing latency or any type of error into the equation. So this is something that we did make it a hearty investment to make sure that we were able to handle all this data coming in and then, of course, getting all this data back out to you. So we've shown this slide before. This is our complete coverage, but to give you a little bit better visual of where we have GNSS coverage, this shows our GPS and GLONASS coverage as of last month, and this right here shows where we have full GNSS coverage relative to the GPS only coverage. Now you will see in a couple areas where you have the bulbous red, that is GNSS network corrections, and then you'll see some circular areas that are single baseline or nearest GNSS areas. So for example, in Canada, we've got quite a few GNSS receivers, but not necessarily enough to do a full GNSS correction and network correction in those areas. So one thing to remember is network corrections are always going to be the better correction type, even if it means losing full GNSS capabilities. So if I am, for example, in Ontario and I want to use the network, we would still encourage you to use a GPS and GLONASS network solution over a full GNSS single baseline solution. The network solution, of course, is going to reduce, mitigate the distance-dependent errors that you see out in the field better than what a GNSS correction would provide. If you're close to a GNSS station or in a very difficult environment where having those additional satellites available to you would benefit you to get a measurement, then by all means, use the nearest correction. But you do want to make sure that you do swap back to network corrections as you move away or as you move into other areas. you always want to check this. We'll talk about this in a few minutes when we talk about mount points, but you want to make sure if you are switching back and forth, specifically field crews, that you have processes surrounding you to make sure that you're on the correct mount point later on if you have switched to nearest to just get a shot in a difficult environments with GNSS, but then you're moving to a longer baseline and you want to mitigate that distance dependent error and need to be on network correction. So make sure if you're swapping back and forth, you know what you're doing. So we have this question come up quite a bit. How do you gain access to GNSS corrections? We covered this in great detail in the earlier webinar this year, but we want to cover it again. First, you do need the ability to use to be able to use full GNSS corrections. You do have to have a full GNSS capable rover. You do have to have the activation codes for your rover, and you do have to have GNSS capable firmware for your rover. One question that was asked yesterday in the previous webinar that I will address here, even if you're connected to a GNSS mount point, if your rover is not GNSS capable or you do not have the codes, it doesn't matter. You'll still only be doing GPS and GLONASS because your rover is not capable or not turned on to process that additional information. So if I want to be able to use GNSS, I do have to have all these check boxes checked along with using a GNSS mount point. So for example, with a Leica Geosystems GS16, a user would need the multi-frequency option. So this covers GPS L1, L2, L5. You would need the GLONASS option, the Galileo option, and the Beidou option, all activated on your rover to be able to take advantage of GNSS corrections. In addition to that, you also have to make sure the firmware that you have is capable of tracking and processing GNSS corrections. For SmartWorks, for example, this means Viva firmware version 615. And this is the GNSS receiver firmware. So the head, the GPS unit itself, not necessarily the controller. You want to make sure that your receiver has the appropriate firmware on it so it can take these corrections in, it can process them and give results using those GNSS corrections. We are keeping a knowledge base open that tracks as we get more information from other manufacturers, from Leica, from Topcon, from Trimble, from Skia, from whoever, about what pairings of firmware is capable of using and processing GNSS corrections. So that's at gnss.snna.co. That will take you directly to the knowledge base article if you have any questions of what my receiver needs to be able to process and use GNSS corrections. In addition to your rover being ready for it from an activation standpoint, you also have to make sure that you're connected to the correct mount point. So we have 3 different mount points that are capable of supporting GNSS. That's MSM IMAX, MSM Near, and MSM VRS. And you'll see here MSM underscore IMAX, MSM underscore Near, and MSM underscore VIRS. If you're using the older RTCM3 underscore mount points, you do have to transition to these new mount points to be able to utilize them. These are available today and work with your existing logins. You just need to change the mount point, and all other your connection details remain the same. We have been asked what we recommend. So it's pretty easy. Anybody with a GNSS capable rover, anybody currently using RTCM3 underscore IMAX, anyone that is not sure about MAC optimizations, anyone still using nearest in network coverage area, and really anyone can right now move over from their existing mount points they're using over to MSM underscore IMAX. When we would heartily and fully encourage this for pretty much anybody right now to move over to this. One question we have been asked on a number of occasions is, why don't we have an MSM underscore max correction available? Well, quite simply is max, master auxiliary concept, does not support the future satellite signals. There is no component, there is no part, there is no place to put those other frequencies, those other signals into the message structure. So that is not a Leica thing, Topcon thing, Trimble thing, Skia thing. That is an industry-wide thing based on the standards of RTCM as specified by the Special Committee 104. Those things have not been added to the RTCM standard to be able to support master auxiliary in L5, Galileo, or Beidou. So we do have to go to an IMAX solution to be able to support that. We talk about IMAX in great detail in the webinar from earlier this year. So again, I encourage you, if you did not see that webinar, to go back and learn a little bit more about it, because we don't want to spend a ton of time on it today, because we got plenty of other stuff to talk about with the pending adjustment and the multiple reference frames. Anybody that's not that has a GPS and GLONASS only rover that is Mac optimized or optimized for Macs, you guys can stay on RTCM3_Max. There's no problem there. But again, we really do encourage folks to start moving over to MSM IMAX so that the transition, because it will take a while to get everybody over, you will start replacing equipment at some point in the future, and then you'll just be used to using this one mount point. If you are in an area that's currently single baseline only, you can use MSM_near. Near should be used in areas without networks. If there's network fixing issues and you can't fix for some reason on the network, or you do want more satellites to go into a more difficult environment, you can use MSM_near. Again, we will stress that a nearest GNSS correction is going to be a weaker correction than a GPS and GLONASS network correction, meaning you're not going to mitigate the distance dependent errors. So we would still encourage you to stay on the GPS and GLONASS network correction rather than going to an MSM near solution in those areas. If you're in a network coverage area, please move to network corrections. We still see every single day folks rolling around right in the middle of great network coverage areas using nearest. Now, this could be because of initial setup issues or initial setup oversight, and you just pick near because that's what we thought we should pick. Or it could be a procedural thing where somebody changed it during the middle of the day because some reason and they never changed it back. Please put in your process manuals. Please put in with your crews that they should check this on a pretty reliable and redundant or repetitive basis. You either check it before they go out in the morning, check it when they come back from lunch, or checking at the end of the day that they're on a correct network mount point as opposed to just nearest. It's going to it's going to impact your accuracies, it's going to impact your functionality and your productivity out in the field to be on single baseline as opposed to being on a network correction. So please, please, please keep an eye on this. Additionally, folks not currently using RTCM 3.1 or higher, that means folks using RTCM 2.3, CMR, or CMR Plus, you are only getting GPS corrections. There is no possibility to get GLONASS and no possibility to get anything other than GPS with these correction formats. This is, again, not an us thing. This is an industry-wide thing. Specifically with GLONASS, there are biases in the GLONASS message. We have to tell you what receiver you're listening to so that your receiver can handle those bias messages. Those components are not available to transmit in 2.3 CMR or CMR Plus. That's the reason that we only do GPS only corrections in these three formats. If you hop on the network and you all of a sudden see your GPS satellites your GLONASS satellites disappear when you're on RTCM 2.3, CMR, CMR Plus, that is not a bug. That is by design because we can't broadcast those bias messages. So this is a problem. So if your equipment supports it, please move to a more modern correction format. Every receiver on the market that we are aware of has the ability to receive RTCM3. It may require an unlock code to receive it, but they have that ability. It will optimize and give you better results in the field if you move to this. The other reason to move to this is quite simply, we will be deprecating all non-RTCM 3.x mount points starting January 2nd, 2018. Primarily because of the support tickets we get saying, I dropped GLONASS. What's the matter with you guys? I'm not getting GLONASS on CMR. Well, we can't give it to you, so we want everybody to get up to RTCM3 so that we can give it to you. This does not affect RTCM 2.3 GIS specific mount points, the GNSS specific mount points. These will not be deprecated. There's only one of those, but if you are on one of these other three, you do want to move to one of the three RTCM3_ mount points, one of the MSM_ mount points. You want to get that done before January 2nd. We will continue to send notices out between now and January 2nd, but please be aware that those will go away start a business on January 2nd. So, fall adjustment. There is a lot to cover here. a lot of information to get through. I know I'm talking really fast, but we still have quite a bit of information to get through on the fall adjustment and particularly the multiple reference frames. So I'll try to make sure we're real clear on what we're talking about in here because it's very, very important to understand where we're coming from and where we're going. We originally did the first adjustment webinar back in 2012, so this is 5 years later. We've done a couple of announcements and a couple of webinars, a little bit smaller in scale since then, but we thought it was time to really go back through this, specifically in the areas that really are affected by our adjustment, to get this out into the back out into the community, back out to for you guys to see here, and there's some things in the old webinar that are no longer really applicable that we wanted to make sure that we addressed. So when we talk about station positioning, we really are about standards with SmartNet. Here in the US, that means looking to adopt the proposed NGS standards. The NGS put out a draft standard back in 2011 about RTN operations. It's not been ratified. There's been some time lapsed, needless to say, where there wasn't a lot of push from NGS to pick this back up here in the past several months. NGS is picking this back up, and hopefully sometime in the not too distant future, we'll have not just a draft standard, but actually a hard standard that everybody can, from an RTN operator's perspective, can start adhering to or looking at, and so that you out in the field have good confidence of what you're getting. But in the draft standards, what we did to adopt this is we wanted to make sure we had an accurate tie to the National Spatial Reference Frame. We also wanted to provide the internal integrity that we require for our operations. So in the standard, NGS does require us to tie to the NSRS within 2 centimeters horizontally and 4 centimeters vertically. We're achieving in and about 1 centimeter in the X, Y, and Z in the Cartesian space. So really, really tight relative to the NSRS NAD 83 NA 2011 Epoch 2010. In Canada, the governing body is NRCan, and here the RTN operators should participate in the NRCan RTK compliance agreement to assure an accurate tie here to the NSRS in Canadian parlance as the CSRS, the Canadian Spatial Reference System, and also to provide the internal integrity we require as well. So NRCan, what do they require? They actually require us to adopt the coordinates they derive for the stations. This means that every year they, for all the stations that we have, they provide us coordinates for those stations, and then having signed the compliance agreement, we've said that yes, we will use the broadcast coordinates that are provided by NRCan. Currently today, we're in about 95% compliance. That means 95% of the stations in Canada do comply with this. The reason that some of them may not be in compliance is either A, it's a new station that's been brought online and we have not received the NRCan coordinates yet, or that a station may be down or offline and we've not been providing RINEX for a certain period of time, so those stations are being marked as non-compliant. So we do great effort to make sure that we're in compliance with NRCan, so that you guys in Canada can feel good about what we're putting out. In addition to making sure that we're in compliance with their standards, we also have our own exacting standards that we try to enforce. And this means that we have to do spend a lot of time, effort, and energy on making sure we check the positions of our stations and calculate the positions of our stations. So we've invested and implemented a full Bernese software suite. This is the highest accuracy processing that's available today. We have a complete cross-check web services, so this is an automated process that happens every single day, so that we have consistency in our results. We're not just sending data off to Opus and getting a random coordinate back. Every single day, this automated process happens in the background, and we're processing station information, and it's all adjusted at the same time for all the stations in SmartNet, so we make sure we have good internal integrity. We do an automated coordinate processing for all new stations. This means, again, as new stations are brought on, they're processed and adjusted in reference to all the other stations of SmartNet. And then we also have our automated integrity monitoring program that we run as well to make sure, again, that we not only have the internal integrity required, but also the information that goes out to the customers can be assured that it is correct. On the internal in the integrity monitoring program, we actually do a 7-day rolling average of positions. This is computed on a daily basis, and this evaluates the coordinates for each station in SmartNet. This means every day we have a new 7-day data set. So we take the last 7-day average and we look at it and we say, all right, if it goes over 2.5 centimeter resultant threshold, then we set off an alarm. This means about 1.4 centimeters in the XYZ Cartesian space would set off an alarm to us if it falls outside of tolerance. We don't actually do anything with this at that point. We do look at it. We look at multipath. We look at different information on the station, but we don't actually update anything until it falls outside of the 3.5 centimeter threshold. This means a 2 by 2 by 2 Cartesian space X, Y, and Z result. And the reason we don't, because the moment that we change a coordinate on a station, it is immediately reflected out into the field. If we hover in that 2.5 centimeter alarm threshold, we look at where it's at, what it's doing, how it looks, all that kind of stuff, and then try to make a good decision if we're going to update it. Typically, we wouldn't do this until one of the fall or spring adjustments when we get the precise position, which we'll talk about in a second, just so that, again, we can check and make sure that it's nothing else and that we do it wholesale all at the same time if it doesn't get to this 3.5 centimeter level. So, a lot of information to cover, but if you give me just 2 seconds, I'll be right back. Sorry about that. Okay, so as we move into the adjustment portion of this, there's a lot of good information, but to make sure we're speaking the same language, I want to go over a few different things. First is processing coordinates. When we talk about processing coordinates, these are the physical coordinates of the stations on the planet relative to IGS. And the reason we talk about processing coordinates is it's really, really important, especially since one of the key things that we're trying to do is model satellite orbital error. The satellite orbits are actually in the IGS reference frame as opposed to the NAT83 reference frame or any local reference frame that may be working in. So if we were using processing coordinates if we're using something besides processing coordinates, a NAT83 coordinate, for example, to actually compute the network correction, we would be introducing meters of noise into that solution, which means that we're fighting through more noise, which it means the possibility of error is higher. So the processing coordinates we actually process on the back end are relative to the reference frame that the satellites are working in, so it keeps the noise level and noise threshold very, very low. In addition to the processing coordinates, we also have the broadcast coordinates. And this is what really matters to you guys out in the field, because these are the coordinates that are used for the computation of the differential baseline between the reference station and the rover. We also talk about non-dynamic stations and high dynamic stations. Non-dynamic stations are stations that have low horizontal velocities, Nebraska. High dynamic stations are stations that have high horizontal velocities, California. And it's really important to understand these as we talk about the different things that we're trying to tackle with an adjustment. So additionally to that, we also have the reference frames that we work in. IGS 08 is our current IGS global reference frame. We will be making a jump to IGS 14 or 18 in the not too distant future to make sure, again, we're constrained to the most recent reference frame to get the lowest noise floor that we possibly can. And this is relative to the IGS core GNSS station network, so the stations that are operated worldwide by IGS. In addition to that reference frame, we also talk about the NAT83 horizontal coordinate system for US, Canada, and Mexico. And there's two different realizations that we really work with SmartNet. One is here in the US, which is NA 2011. And then, of course, we have CSRS, the Canadian Spatial Reference System, in Canada. So we have the NAT83 reference frame, and we have the realization NA 2011 or CSRS in Canada. We can kind of swap in when we talk about a realization and say NSRS, this is just kind of generically referencing both the US reference system and the Canadian reference system, so you don't really get specific to it. So if I say NSRS, I am talking about NA 2011, NAT 83 NA 2011 in the US, or NAT 83 CSRS in Canada. We also have the Epoch date, and this is the date that the coordinates are referenced to, not necessarily published on, but referenced to. So for example, in the US, the common reference frame and the common epoch that we work in is NAT 83 NA 2011, Epoch 2010. You guys have probably heard this before. In California, though, we continually update this epoch, spring and fall cadence to make sure that we account for the movement of the stations across plate boundaries. So now we kind of define the language that we'll be working from. We need to talk about when we'll be doing this stuff. So when is all this going to happen? When is the fall adjustment going to happen? So just so you know, preparations have been completed. That means all the calculations have been done, all the adjustments have been completed. Our execution plan is in place. QA and QC is underway. It's in its second of 3 phases. Final phase wraps up before we publish next week. So second phase wraps up this week. Third and final phase wraps up next week, and then we begin publishing the coordinates as the next step. So this is a lot of time that we spend to do this. We take this very seriously because any changes that we made do affect you out in the field. So we will be publishing new coordinates on starting November 12th at 10 p.m. Eastern Time. So the network will go offline on November 12th, so that's Sunday night a week from now, to go offline to start bringing in and not only bringing in coordinates, but also updating Spider as well. Earlier, you heard me talk about processing coordinates, and this is a slide that we showed way back when in 2012 when we first introduced the new adjustment. And this actually was Spider 4. We're on Spider 7.1 now, or about to be. So back in Spider 4, a single coordinate was used for processing and broadcast, and this caused a lot of problems. Not only did it adversely affect the quality of the network solution that was available if you allow too much time to elapse between updates, but specifically in areas of movement, so high dynamic stations, users experienced inconsistent network processing results, or in areas where the adjustments of the coordinates were immediately reflected to the user. This means if I, as a network operator, wanted to update the coordinates because the network solution was kind of falling apart because the stations were drifting apart too much, then these were immediately reflected to the user. This is not necessarily a good thing. So what happened is we separated the processing and the broadcast coordinates. This allowed us as a network operator to be able to adjust the processing coordinates in the back end to optimize the network processing, but it also allowed you, the user, not to have to necessarily do that every single time we stepped forward. This is important both in areas of movement, but also wider. It's also important in areas of non-movement or non-dynamic stations. So if we need to update the coordinates, the processing coordinates in Texas, for example, now we have the ability to simply take the network offline for a few minutes, update the processing coordinates, and bring it back up. And by doing this, we now have a network solution that fits together better, but it never affects your vector measurement. So where your reference station, or excuse me, where your rover measurement is referenced to in the field, back to the reference station, because we didn't update that broadcast coordinate. So it's really a really good solution as a network operator, where we can update it to make sure the network integrity holds, but it doesn't immediately impact the users out in the field from a relative baseline measurement. So processing coordinates. We do a 2-week precise position, and this is computed on a semi-annual basis. What this means is we take 2 weeks of data, we then wait 2 weeks, and we get a precise ephemeris, and then we process. We compute this semi-annually, meaning twice a year, spring and fall, and then we update for all stations across the entire network, all the processing coordinates twice a year, spring and fall. So we take the network down for a few minutes, both in the spring and the fall. We update all the coordinates in the back end, and then we make sure everything fits together well. For you as a user, these are transparent, these are hidden, these are behind the scenes. You guys never see this. Processing coordinates are always in the most current epoch. So epoch 2018 750 will be what we're, 2017 750 will be what we are moving to, and we will publish these and make these live on November 12th. Again, these do not affect you if you're using them anywhere. That's only on the network side. You don't have to worry about it. It does not influence the measurements you make on the field as far as the relative vector. It will influence. You will have a better, more consistent and stable network solution by us doing this, but it will not change how you measure out in the field. Okay, we do update them all, but it doesn't affect you out in the field. Broadcast coordinates, however, when we change those, they do affect you in the field. We do this the same way. We take the same data set that we use to compute our 2-week precise position with our processing coordinates, and we take that and do the same thing on the broadcast coordinates as well. Broadcast coordinate updates do affect you, as I just said. In California, they are adjusted semi-annually, spring and fall. So folks in California are used to this now. Every spring and every fall, their coordinates creep along in the same span of as the tectonic plate movement that you see in California. So annually, we see 3 to 5 centimeters of movement in California. So in the spring, you see movement about 1.5 centimeters to 2.5 centimeters relative to our fall coordinates, and it just keeps moving along as we go. We've evaluated Washington and Oregon on an annual basis. There's not quite as much movement. We are on a 2012 250 epoch in Washington and Oregon, which we will be updating this fall to 2018 to a even epoch. Louisiana, we evaluate annually, not for horizontal movement, but for subsidence issues. We're not seeing quite enough there to make a big change in station coordinates. We do have a couple stations that we need to look at, and if we do make a change, we will update everyone on those. Non-dynamic stations are evaluated on an annual basis. Unplanned updates may occur after a seismic event or a large displacement has occurred. Again, that's in alignment with the thresholds we talk about with the integrity monitoring program. So we look at this every year for all the stations. We look at California spring and fall, and we do adjust those in the spring and fall, and that's where we're at right now. So broadcast coordinates, what does it mean? Non-dynamic stations, we are in the NSRS common epoch with a current class. We'll talk about classes when we talk about multiple reference frames in a second. So in the US, our common epoch is NAD83 NA2011 epoch 2010. In Canada, it's NAD83 CSRS epoch 2010, and that's what we are broadcasting. And non-dynamic stations will not be updated when we publish this coordinates here in the next week and a half. They will remain the same. If there is a station that is problematic or we see an issue with during our evaluation process, we will update that station, but we will also advise the community that station has been updated. For high dynamic stations, that means a current epoch and a current class, and again, we'll talk about classes in a few minutes. The coordinates are NAD83 NA2011 epoch 20, whatever we're moving to in California, Washington, or Canada. So in California, for example, we're doing a current adjustment for California. It will be published on the 12th. The broadcast coordinates of that station will be NAD83 NA2011 epoch 17.750. This is no change from our normal process. Washington and Oregon, however, will update. They haven't updated so far, but they will update, and they will update to a NAD83 NA2011 epoch 2018. Canada, we don't have any stations that fall into this, but we wanted to keep that open and make you aware of it. So a lot of information. Okay, processing coordinates are calculated, updated. They're behind the scenes. They don't affect you. Broadcast coordinates are calculated. California, they are updated. The rest of the areas, they are evaluated. These do affect you. If it's going to be a change that affects you, we will notify you of that change. So you will see an email going out to everybody in California saying, remember, adjustments on the 12th, these coordinates are changing. Be aware of this. Washington, Oregon, same thing. Adjustments on the 12th. We're moving to 2012, moving from 2012 to 2018. this will affect you. Please be aware of this. Everything else will stay the same unless the station falls outside of tolerance. Then it will be updated, and there will be a knowledge base article that says this station has been updated. Additionally, you'll also see information in the history, and the superseded coordinates for that station will be updated, so you will see that in the history so that you can be aware that that station coordinate has changed. Now, as we change coordinates, the question always happens, what if I need something different? What if I want to get back to the common reference frame? What if I want to get back to the left reference frame in Epoch? What does this mean? How can I handle this? Well, back in 2012, we put this slide up, and we thought we had this grand plan that we're going to provide a transformation, with a disclaimer, of course, for download that allows you to manually enter or to download and project back in time to a common reference frame or to the last adjustment. And we did put an asterisk on there and put that was under development because it was a big, hard math problem to have to work from. So we tried to do this, and we could never get an accurate transformation calculated or created that didn't have issues, especially in areas of movement. This is because we didn't have enough data. We didn't have velocity grids. We didn't have velocity models. We didn't have distortion models. We didn't have a lot of additional things that needed to be rolled into this to produce a hyper accurate transformation that would work anywhere in the service area you're talking about. Particularly along the plate boundary, things started to fall apart. The problem is the plate boundary doesn't occur out in the middle of the desert. The plate boundary occurs right in the middle of San Francisco or right in the middle of LA County. So this is a problem that has to be tackled. So what we've done now with 7.1 is we are now introducing the ability to broadcast multiple reference frames, and this does affect both high dynamic areas as well as places where legal requirements want additional reference frames to be available to work from. So in high dynamic areas such as California, Washington, Oregon, we will be able to have a multiple reference frame situation where we can broadcast additional coordinates, additional reference frames. And the same thing, for example, in British Columbia, where on Vancouver Island and the BC mainland, there's two different reference frames and epochs that are required to work from. So in areas of high dynamic motion, we do have the ability now to not only broadcast the current epoch, but we'll also have the ability to do the last and the common epoch as well. So in California, we talk about the common. This is NAT83 NA 2011 Epoch 2010. Last, we talk about NAT83 NA 2011 Epoch 2017 250. So this is the last epoch that we were actually on. And we talk about epochs and stuff here. We're going to talk about classes in just a second, which kind of starts separating these just a smidge because of what's coming a little bit further down the line that we have to kind of keep an eye on. In Washington and Oregon, we have the common epoch that we have to work from, which is NAT83 NA 2011 Epoch 2010. And we have the last epoch that we had to work from, which was NAT83 NA 2011 Epoch 2012 250. In British Columbia, for example, we have to try to stay in compliance as best we can with the statutes and laws. It does want us to have a different epoch available to work from. So in British Columbia, Vancouver Island wants NAT83 CSRS Epoch 1997, and BC mainland wants NAT83 CSRS Epoch 2002. And this is a reference to the Survey General Circular Order 463. This means that we come into alignment with these requirements to the best of our ability to broadcast out a coordinate in the epoch that is required in those particular areas. Now, to do this, we have to talk about how we do it. So how do you access multiple reference frames? First, we have to break coordinates into class. Now, you heard me say earlier, current epoch, common epoch, last epoch. Okay, and we have to look at this now not in epochs but in classes. But we say we have a current class that we're working in, a common class, and a last class. And the reason for this is when we talk about this, we have not only the epoch but also the reference frame that we'll be working in. So there's two things. So the class is the pairing of those two things. In legal requirement areas, we have the common class and alternate classes that we need to work from. So we talk about the classes first. Second, we have to create a specialized mount point that pairs the frame and the Epoch together, which creates the class. So the high dynamic areas, we have the common class, and the last class that we worked from. The legal requirements have the alternative class, and in this case, we have two different alternative classes that we work from, 1 and 2. So specialized mount points are structured. This means we have the correction format, the correction type, and the Epoch. So you can see the top one here specifically is for the BC area. So we have RTCM3, which is the correction format, IMAX, which is the correction type, and 1997 is the actual Epoch that we are referencing as part of this. Additionally, we have MSM, IMAX. And this would be for California, for example. We have the MSM, which is the correction format, which is RTCM3 MSM. We have the correction type, again, IMAX, and the Epoch 2017_250. The reason that we have the _250 is if we push 17 and 250 together, it's kind of hard to discern and look and see. So we wanted to break that out because 7 and 2, when they're kind of squished together, look the same. And we didn't want anybody to have the chance of making a mistake because this will immediately affect your measurements out in the field. So in California, we will have a lot of different mount points available to you, but this shows you the schema that you would be working from. So in California, your coordinate class of current, so that means the current Epoch, the current information, the current most frequent or the most recent update to the coordinates in California are what are going to be available on the standard mount points. And then we made a conscious decision to do this because we don't want you to have to think about what you're changing. Okay, so the current mount points that we have, RTCM3 max RTCM3 underscore IMAX, etc., will continue to move as we always have moved them through time. So that means they will automatically update. You will automatically get those updates unless you switch to one of the multiple reference frame mount points that are available on alternative ports. So in California, the current class RTCM3 underscore whatever is on port 10,000. We'll have a reference frame NAT83 NA 2011 with the current Epoch 2017-750. Same thing for any of the other mount points, MSM underscore whatever, port 10,000, NAT83 NA 2011 2017-750. To get to a common coordinate class, so that you want the NAT83 NA 2011 Epoch 2010 reference frame, then you have to go over to a different source table, a different port. Here, 11111. Again, we wanted this to be visually distinctive from 10,000, so there was no chance that you accidentally, oops, I meant not 10,000. I meant 10,001. We don't want that to happen. We want it to be visually distinctive. So you go to port 11111. You will see now mount points RTCM3 underscore whatever correction type underscore the Epoch 2010. And this would be NAT83 NA 2011 Epoch 2010. And additionally, we'll have the last class, which is RTCM3 underscore whatever the correction type is, 2017-250. So you'll see the Epoch right in the name of the mount point available to you so that you can go to work. So this is an example, and you can substitute, of course, max, IMAX, near, or VIRS into the corresponding and correct mount point schema above. Excuse me. Oops, back on. Washington and Oregon, we'll have the current class. We are moving our standard mount points up to Epoch 2018 for Washington and Oregon. We do have the common, and then we also, in Washington and Oregon, will have the class that we're currently broadcasting in, which is 2012-250, available on that alternate source table mount points so that you can get back, should you want to what's behind you. So this is example mount points. If I have a current class, all current classes are going to be on port 10,000, RTCM3 underscore IMAX, MSM underscore IMAX. You'll have the common coordinates available to you. Common, port 1111, RTCM3 underscore IMAX underscore 2010. Or MSM underscore IMAX underscore 2010, or port 1111 will also have the last class RTCM3 underscore max underscore 2017 underscore 250. So you'll be able to get to what was currently being broadcast. You'll be able to get to a common broadcast, or you'll be able to get to the last broadcast based on the mount point that you select on your rover. So this gives you a lot of flexibility out in the field to do what you need to get in the appropriate reference frame or epoch. In legal requirement areas such as British Columbia, we're doing something very similar. Our current class will be in, of course, Epoch 2010. So you'll see RTCM3, port 10,000, NAD83, CSRS Epoch 2010, and then we will have our two alternate epochs available to you, RTCM, both 1997 for Vancouver Island and 2002 for the BC mainland. So in these legal requirements areas, for example, folks that are currently using RTCM3 underscore IMAX will continue to get the common 2010 epoch. With port 1111, RTCM3 underscore IMAX underscore 1997 will provide you the requisite epoch for Vancouver Island, and then of course underscore 2002 will provide you that requisite epoch for the BC mainland. So this all ties together, makes it very easy to transition between common or the two alternate epochs that you want to run into. One of the keys and one of the reasons that we haven't done something different in the past, specifically when I'm talking about here in BC, is there's only a small body of water that separates the BC mainland from Vancouver Island. So if I'm on the island and I happen to be working on close to a station, and that station drops out, and the next closest station happens to be over on the mainland. In the past, if we had just said, okay, we're going to broadcast 97 for these stations, and 2002 for these stations on basically the same mount point, then it would automatically hop over to the BC mainland that have coordinates that don't comply, that don't look like, that aren't in the same epoch as what's on the island, and you automatically see a big jump and shift in your coordinates. And this is one reason we didn't want to do this, because it's not the correct way. Now what happens is we will actually be able to put Vancouver Island coordinates or epochs on some of the boundary stations on BC mainland, and so if you do jump across to the mainland stations for some reason, it will have the appropriate epoch coordinates assigned to them, so that you will continue to work in the right epoch for where you are working. This is a really key, important port, and it also lets you know what you're getting. So if you go work on the island, you know that you're getting 1997. If you go work on the mainland, you know you're getting 2002, and you're in good shape, so that we make sure that we come into alignment with what your requirements as customers are. Now, the key here is making sure that you switch if you transition between those two areas. So make sure you pay attention to that when you're working from it, because it's really important not to mix those two things up. So that's multiple reference frames. It's a really complex topic. From a field use, it's pretty simple. You pick the mount point that's associated with the reference frame that you need, and that is what we deliver to you in the correction. So from a usage standpoint, it's very simple, but understanding what we're trying to do is a little complex. In addition to multiple reference frames, you now also have to have the ability to track coordinates and epochs and the classes associated with them in a place very easily. So we are completely reworking the SOT database to make sure that these types of things are very easily to surface and to be visible. So in the US, you will be able to find, of course, as you have in the past, the processing coordinates. So that's the IGS 08 current epic for all stations. You will be able to find the NSRS common epic for all stations. You will be able to find the current epic 2017-750 for high dynamic stations, and you will also be able to find the last 2017-250 coordinates in areas of high dynamic motion, for these high dynamic stations as well. Plus, you'll be able to find any superseded coordinates as well. In the Canada, you'll be able to find processing, common, current, and last, just as you do with in the US. In addition to any superseded stations, so you'll find the IGS processing, you'll find the CSRS Epic 2010 for all the stations, and then in high dynamic stations, you'll find the 2017-750 or 250 epics as well. We don't have any of those in Canada right now, but if we did, you would be able to find them. For example, in an area like British Columbia, where you have alternate coordinates or alternate information or classes that you need to use, you'll find the processing and the common just as normal, but you'll also find Epic 1997 for Vancouver Island, and you'll find Epic 2002 for BC mainland, plus any other superseded coordinates that are out there for those particular stations. So what does this look like? Well, the site database hasn't changed in this regard. You'll still go to the site database. You'll scroll down to position information, and then you'll see the current NAD 83 position. Okay, and so this is the current broadcast coordinates, and this is why we current the current class because it is current broadcast. Then if you click coordinate class info, you will then see the different classes that are available for that particular station. So if you were working in California, you would see the current class, you would see the common class, and you would see the last class all in here so that you would know what are available for broadcast just by glancing at this. Additionally, you would see any superseded coordinates from previous epics or previous adjustments that were part of this as well. So this is really important so that you'll see it. You will also see if it was a BC station, you would see current class, and then you would see alternate, and then you would be able to identify the reference frame and the epic that they're operating in by simply glancing here. And then you would actually be able to click and view the coordinates as well. So all this information is going to be in the site database and be available at your fingertips. We do have some reports back, and we are very, very, very aware that there is some graphical issues right now with the site database, displaying either the wrong reference frame or the wrong epic. This is a graphical issue. This has absolutely zero to do with what is actually being broadcast or what is actually stored in the database. It's just a graphical issue. This was reported a couple times in the past several months. We are well aware of it, but there are a lot of things going on where we decided not to touch this because we knew that this new multiple reference frame thing was about to come about, and we wanted to spend all our development resources to try to get it right when this launches. So soon after launch, November 12th of the new Spider, the new reference frames, the new multiple reference frames, there will be a wholesale change to how this works in the background to make sure that you're always seeing the correct information as it is in Spider right now today. That means that the portal will call Spider, it will pull the information in so that you can trust exactly what's in the portal matches exactly what's in Spider, so there is no ambiguity of what's being transmitted or what is available for that particular station. So these are key things we're aware, and we're trying to develop it so it's even better. The next question we'll probably be asked is, okay, well, there's a lot of coordinates, there's a lot of this, there's a lot of that. I can see the classifications here, but how do I get to it on the, how do I make sure I'm getting to the right thing on the real-time products? Well, we have a new connection and configuration page that will be deployed on the 13th, and this allows you to select your rover manufacturer, your rover model, your service area, and then once you do that, it will show you the server address, and now the mount point information will be down here below that, where it'll have your port, It'll have your mount point with your mount point name and then the specific reference frame that those mount points are actually operating in for the service area that you have selected. For example, if I pick California, my port 10,000, my current class is 2017-750, and you will see that that is the Epoch broadcast that I will be getting for operations in California. So this is really key to understand what you'll be getting, and this will be launched along with the multiple reference frames later in about a week and a half. So you'll be able to see this very easily. You won't have to remember everything that I've said today. You'll be able to come here, select it, and you'll see, oh, these are the reference frames that are available for my area. This is the epochs that are available, and these are the mount points that those things are on. So you'll be able to put that in your rover and go to work. Now, having said all this, again, it is critical. It is absolutely critical that you understand that changing your mount point to one of these alternate reference frame or epoch connections will affect the measurements in the field immediately. Okay, there is, again, 3 to 5 centimeters of movement a year in California. So if you pick the Epoch 2010, that means there is somewhere between 20 and 40 decimeters of movement between your Epoch 2010 and the current Epoch. You will see a gigantic jump in coordinates. So you need to make sure from a process standpoint that your guys in the field understand what they're selecting if they are making changes, because it will immediately affect you in the field. Okay, this, of course, what mount point you're connected to will be stored in your detailed log files. So if you have a question about it, you can look at your detailed log files. If you are a Leica user, there is a checkbox that says show RTCM3 welcome message. And it also, there's another checkbox that says show and log RTCM3 welcome messages. Check that, because we will be broadcasting, welcome to SmartNet, you are connected to this. And you will check and show in your log file that you are connected to this particular epoch and reference frame in your RTCM message, so that you will have that available to you in your data that you download from your data collector. And again, it's still in your detailed log files as well on the portal. So you can go and look. If you see a problem, you can look and say, oh, they were connected to the wrong mount point. Now you can fix that by updating your coordinate using the SOT database. So there's a lot of ways around this, but you got to know what you're doing, because you can get yourself in a lot of trouble if you don't. So a few things on the horizon. One of the reasons that we're doing this in anticipation of the next really monster change, which is NGS has announced the move to a new geometric and geopotential reference frame in 2012. This replaces NAD 83 and NAVD 88. This is a new vertical datum, which will be a geopotential datum, which will change heights in the frame of about 50 centimeters. Okay, this means this reference frame, this geopotential and geometric datum is no longer reliant on passive geodetic markers and terrestrial techniques. This is a completely GNSS defined reference frame and datum that we'll be moving to. This integrates navigational GNSS and mapping GNSS reference frames. So currently NAD 83 is offset from IGS by a meter and a half, 1.7 meters, something like that. Basically, the center point of the origin of the reference frame is different from IGS. These bring those two things in closer alignment, so that if I'm navigating, my navigational and my mapping reference frames will be closer together. This is important as we move towards autonomous vehicles and other really cool stuff, that these two things kind of come together a little bit closer. And our accuracies relative to sea level will improve dramatically over the current geoid models that we have. We'll see a 2 centimeter accuracy relative to sea level. And this is the reason that we talk about going to classes as opposed to necessarily epochs, because when we move to this, we'll be on a new reference frame and we'll be on a new epoch. So we will have the last class will actually be NAD 83, NA 2011, Epoch 2010 will be the last class that we were working on. And our now current class will be whatever we're calling 2022. I don't think the name's been defined yet, but whatever that is called for 2022 will be our current class. And that will affect everybody, not just folks in high dynamic areas. So that's the reason we're talking about classes as opposed to just epochs now, because we do have a completely new reference frame and epoch that are near on the horizon. And I say near, we're talking 4 years out, but it will be here before we know it, and we want to make sure we don't have to wholesale change the terminology that we're talking about 4 years from now. Additionally, on the horizon, again, we have the Spider upgrade on November 12th to allow us to do the multiple reference frame launch, and we have the fall adjustment and coordinate update on November 12th to handle this as well. So November 12th is a big day. So we will be working very hard between now and then to prepare and get ready for it. And on the 12th, we will put all this stuff in place running into the next morning. And then by start of business the next morning on the 13th, and I hate to say 13th, it's the ugly, unlucky number, but we're going to say it anyway. On the morning of the 13th, all this goes live for you guys to use out in the field. Additionally, we also have our continued GNSS infrastructure rollout, which will continue to upgrade hardware as well as upgrade codes to make sure that everything we have out there that's GNSS capable has GNSS activation on it so that you can use it. We also have new Rhinex packages and programs that are going to be available starting in Q1 2018. We wanted to get past all this other stuff before we rolled that out. This will allow some more flexibility. You will see that we drop down on our Rhinex packages and programs a little bit earlier this year, down to 30 days. One of these things was to be able to take all this new GNSS data in. We had to cut something, so we did shrink that down. But it also means that we are, when this new program launches in Q1 2018, all stations will move to 1 second data. Currently, we kind of have a hodgepodge between 1 second and 5 second and 30 second because of different constraints. But we'll move all of this to standard 1 second across the board for all stations for that 30 days. We'll also be introducing XBOSS, which is a Rhinex API service that integrates with different software platforms such as like Geosystems Infinity. And again, this will be rolled out in Q1 2018. Now, this does present some challenges with XBOSS because of how we're going to have to roll this out. So we will have another webinar as we approach XBOSS rollout to discuss this in a little bit more detail. But this is something that's near-ish on the horizon. But right now, the most important thing to us is get this new version of Spider up, get these multiple reference frames up and operational, and get this going for you guys out in the field. So wrapping up, I want to give a quick wrap up. We've covered a lot of topics today. I've talked really fast because there's a lot of information that we've had to cover. So want to make sure we hit the high points real quick and answer any questions that might have been out there. So one question we do get asked quite a bit is, how do you find out about the status of SmartNet? Well, we have a couple different ways and a variety of different tools available. So if we want to look at the overall system status, you can go to status.smartnetna.com or the really short one is stat.sna.co. And this will show you a status page of the operation at a system level. So it breaks it down in each individual regions and shows you that corrections are available, that data is available, that there's no problems, that there's no incidents or anything like that. So if you are wondering, is SmartNet available? This is a great place to go. You can call your dealer. Your dealer is going to put in a support ticket. You're going to put a support ticket. Hey, is SmartNet offline? The easiest thing to do is go right here. You don't have to send the support ticket. This is an automated monitoring system that's set up. So if it's offline, this will tell you it's offline. We monitor mount points. We monitor availability of ports. We monitor all sorts of different stuff, all automated on the back end. So if something goes wrong, it is immediately automatically posted to this page. We get alarms. You can have visibility to it, so it's really, really great as opposed to having to go through the telephone chain of calling your dealer calling us telling the dealer, no, everything's fine, and then calling you and say, hey, everything's fine. You can just go here and look, and 99.999% of the time, everything is just fine on the network, just so you know. Station status. So if you don't care about necessarily overall system status, but you want to get down to the station status level, you can go to the live status map. Of course, you log into the portal and you can go to live status map, or you can just go to live.smartnetna.com, or the short one is live.sna.co. In addition to that, we also have our announcements and miscellaneous information is always posted on Twitter. So you can always find us on Twitter. That is also in the portal, shows all our current stuff. But we also use Twitter to get announcements out. maintenance, critical information, those type of things. We put it there as well. And we use this also as external service because if something happened to our infrastructure, for example, the portal wasn't there for some reason, we now have two ways to get that information out. One is the status page, which is up at the top, and the second is Twitter, so we can communicate that information out, and we're not reliant just on our portal. So use these tools. They're really handy, and we do keep them up to date. So GNSS launch, does it affect you? If you want GNSS corrections, yes, it does. You must update the mount point you use to be able to get GNSS corrections. We have had a number of questions about this. Hey, I have a GNSS rover. I activated all my codes. I've done all this stuff, and I log in, and I drop down to just GPS and GLONASS. What's my problem? And then we ask, are you on, what mount point are you on? I'm on RTCM3. If you're on RTCM3 underscore anything mount point, you're only going to get GPS and GLONASS. You're not going to get GNSS. You do have to move over to MSM to be able to get those. If you're using a legacy format, does this affect you? Yes. If you're using RTCM 2.x, CMR, or CMR Plus, these are being deprecated on January 2nd, 2018. You do want to update the mount points that you're using. If you care about GPS and GLONASS only, does it affect you? No, it doesn't. You can stay right where you are. You don't have to change anything. Everything's going to continue to work just like it is. We're not killing the old mount points, RTCM3 mount points anytime soon. But we would encourage you to go ahead and move over to MSM IMAX because trying to get everybody onto one platform has a lot of benefits for you and for us as well. The adjustment, does it affect you? Does the fall adjustment affect you? If you're in areas of non-dynamic stations in the US and Canada, so about 90%, 95%, 92% of the network, does this adjustment affect you? No, we're not updating broadcast coordinates. The only effect is the network will be down as we update processing coordinates, but it will not affect you because we're not moving station coordinates around. If you're in high dynamic stations, does it affect you? In California, yes, it's the same as your normal spring or fall adjustment. There's no big gigantic changes in process or procedures here. So you see the exact same thing you see every fall and every spring when we do this adjustment. However, you now will have the ability to use a multiple reference frame mount point to get to the common coordinate class or get to the last coordinate class as well. So you can move back in time should you need to. If you're in Washington and Oregon, does this affect you? Yes, we will be doing our first update since we took over the network, so you will see a shift, and the shift has become pronounced enough to affect the measurements in the field. We will be updating to NAD 83, NA 2011, Epoch 2018, so this will affect you. You need to be aware of it. You need to be taken into account. However, with the launch of MRF, the multiple reference frame, you do now have the ability to go back to the common coordinate class to 2010 if you should need to, or go all the way back to 2012 250 should you need to use the last coordinate class that was available. So you do have that option. Multiple reference frames, does it affect me? Will MRF changes affect the mount point I use? The simple answer is no. Non-dynamic stations in US and Canada have one coordinate class. That's current because the current class is the same as the common class. There is no difference between them because we're working with the same pairs. Again, a class is made up of the reference frame and the epoch. So if the reference frame and the epoch are the same in current and they're the same in common, there is no effect, there is no change. Multiple reference frames are an addition to what you have available to you, not a wholesale change of what you have additional to you. You can choose to use them or you cannot choose to use them. And this is one reason we're bringing them on when we are. Standard operations and procedures do not change. If you are not going to use a multiple reference frame format, then your procedures are not going to change. Your standard broadcast coordinates update in California just like they do every 6 months. So if you always do a new transformation immediately following that, then you can continue with that process, or you can start using multiple reference frame mount points to go back in time. That is your choice. But quite simply, the answer is no. So finally, we've covered a ton of information today. I've talked really fast, and I apologize, but we are recording it, and the recording actually works. So if you watched it yesterday in live, you now have to watch this again and hopefully pick up a little bit more information. We always cover this slide last in every presentation we do, sometimes first, but most of the time last, because we really want to reinforce this is how we make decisions with SmartNet every single day. If we kind of stray from anything, this is what we look at to get us back on track. But when we make a decision, we really look at this to make sure that we're living up to our commitment to our customers out in the field. And this is to provide high precision, high availability network RTK corrections, provide them in a GNSS corrections in an industry standard format, RTCM, provide GNSS corrections for all precision industries, survey, engineering, monitoring, GIS, DGPS, agriculture, construction, and maybe new ones that are coming out every single day. Provide a stable and reliable infrastructure on a standard reference frame, or now multiple reference frames, and provide the complete customer experience, service, support, and online tools. And we try to do this every single day in hopes that we live up to what you guys need in the field and can tackle that as we go. As always, we're always available for questions. You can visit www.smartnetna.com to find the website. Go to contact us if you need to. You also can always reach us at support@smartnetna.com. Again, support@smartnetna.com. This will send an email right into the ticketing system, and we can get all the information that we need to, or get you all the information that we need to via the ticketing system. So I thank you guys for your time and attention. I'm sorry that the recording yesterday was lost. There were some good questions yesterday that we got to answer, but if you do have questions or do need to go back over that, please feel free to contact us. We'll get this posted here in the next few hours so that it's available. And thank you guys for your time and attention, and good luck out there.